Hello and welcome. This is a demo for assignment 5. We are group number 21. I am Harsimran and this is my group member Prathamesh Chaudhary. We are going to give you a demo of assignment 5. We'll start with downloading the zip file. So let's extract the file. So now we'll open this in Visual Studio Code. So this one. Yep. So we'll start with these are the three functions. These are the three Java classes which have written. This is the state one where we have defined all the states. This is the test code, like the test drive code where the test is written, and this is the Gumball machine Java code, and this will be explained by Prathamesh.
Yeah, the state pattern, basically the state pattern is a behavioral design pattern that allows an object to alter its behavior when its internal state changes. And also in simpler terms, we can say that the pattern helps an object behave differently uh, based on its current state. And the behavior can be encapsulated into the separate classes. So according to this, it's just a phenomenon which changes the state conditions, and we can manage the state patterns questions with more ease. Here you can see in Gumball machine that if the count is greater than 0, it means we have some number of Gumball balls in. So the state will be a no quarter, and else if it is less than 0, then the machine state will be a sold out. So based on these conditions, are all the uh, classes will changes its state, and automatically the below program will get direction. So next will be explained by the Simi.
Okay, so I'll just explain you the insert quarter, eject quarter, and the turn crank functions. In the insert quarter, we have just implemented a basic, can say the condition where we'll check if the current state is not equal to sold out. We will increase the current inserted quarters. We have defined one more variable over here, which will keep a track of how many quarters are there in the machine. And based on that, we'll be calling the insert quarter function or eject quarter function. Even the same condition over here to reduce the number of quarters if you're going to eject the quarter. Similar the turn crank function, it will only activate if the two of the states are satisfied. Then only we will be able to dispense the uh, gumball machine. The release ball function is the function where we are just going to print a message that a gumball is coming out of the machine, and the count will reduce the count. So these are the refill function, get count function, and the toString function. This is nothing but the basic template of the output message which will be printed at each and every interval. So these are different states as explained by Prathamesh. We'll be going to no quarter state if the count is greater than 0, and if it is less than 0, then sold out state. So this is the state where the machine will have one quarter. Similar, this is for two quarters. This is for no quarter. This is for sold out, that is, and this is for winner, and this is for this is the random generator which we need to generate the random winner. So we have used that random function over there. So this is the sold out function over here. Yep. So we have defined, we have changed the functionalities here and there as we had to change the functionality from one quarter will eject a gumball machine to two quarters will be required to eject a gumball machine. So eject a gumball from the machine. So as you can see, we have changed the print message over here. If you insert a quarter, it will tell you that you have to insert another quarter, and we will be redirected to has two quarters state. Similarly, the eject quarter and turn crank functions has been modified. You can't turn the crank as uh, there is only one gumball in the machine, the one quarter in the machine, so you can't turn the crank. Similarly, for two quarters, as you can see, you can't insert one more quarter because there are already two quarters, which is the maximum limit of a machine at a moment for it to turn the crank. So as two quarters are there in the machine, we can turn the crank, and we can choose whether the winner is predicted or not. So as we have kept the winner from the bound of 0 to 9, as we are given a condition that 1 out of 10 people should be a lucky winner. So that is why we have kept the bound as 10, and we have randomly decided winner value as 6. It could be anything which you can set based on your requirement, but we have set it to 6. If the value is 6, then it will be a winner, otherwise it will be just a sold. That is, a gumball will be sold to the person. Dispense function will be just used to print whether the gumball is dispensed or not. Since over here uh, we have written like two quarter function, a two quarter state, a sold out state, and a sold state. Similarly, all the other states have been written, and we can see that there is a winner state as well over here. So for the winner state, we have dispense function, which is pretty much modified, which will actually check if we have more than 3 gumballs present in the machine, then we will release the 3 gumballs and say that you are a winner and you have 3 gumballs for one quarter which you have entered. But if we have only 2 quarters in the machine remaining, then we will say that sorry, we only have 2 gumballs left. Though you are the winner, but you only have 2 gumballs left. So only 2 gumballs will be released. Else only one gumball will be released. If the count goes less than 0, we will enter into sold out state. That is this one state. Similarly, all the states has been written. Now I'll just walk you through the code, like the output of the code. So yeah, so this is how the output has been printed. So I'll just walk you through each and everything. So this is the test case one where normal operation will happen. We will first print the state of the machine, then we will insert a quarter, again print the state of the machine, insert another quarter, then print the state of the machine and turn the crank and we'll print the machine. So basically this in this case scenario, we can see that the number of quarters currently inserted are 0. This is the first print machine. Then secondly, we have inserted a quarter. The one quarter is showcased over here. Now we have inserted another so 2. Now over here, when you turn the crank, we have written over here you have turned, and luckily in this current scenario we became a winner. So that's why this particular message has been displayed over here, and 3 gumballs are ejected. Okay, so now it is also showcasing how many gumballs are remaining in the machine. Earlier we had 10, now we are having 7. So this is another test case scenarios where we test the eject operation. Similarly, we have showcased all the different kinds of test scenarios. So in this second one, we'll be inserting 2 quarters and we'll be printing the gumball machine. We'll eject 1 quarter, again print it, again eject 1 quarter and print it. So basically it should reduce the number of quarters inserted, right? So now over here we can see that we have inserted 2 quarters. So the value is 2 right now. We have a quarter returned, that is we have rejected 1 quarter, that's why the value returned back to 1, and we have again rejected 1 quarter, so the value came back to 0. So now the test case 3 is basically when we try to turn the crank when we have 1 gumball less. So over here you can see uh, we have entered 1 quarters over here, and we have entered 2 quarters right now, and we have written 1 quarter. So we only have 1 quarter left, and when we have 1 quarter, we are trying to turn the crank. So we have inserted 2 quarters, we ejected 1 quarter. So right now we only have 1 quarter in the machine. We printed the gumball machine, we turned the crank. So as we only have 1 quarter, it is going to print this message and it won't allow us to eject the gumball from the machine. Again, we have ejected a quarter and we have printed it. So right now we have 0 quarters in the machine, and we try to turn the quarter, a crank, but we don't have any quarter in the machine. So this is the test case 4 where we are going to actually iterate the for loop to check if we don't get any winner in the previous case scenario, we can just try to find a winner over here. So for 7 iterations, it will just try to insert 2 quarters, turn the crank, insert 2 quarters and turn the crank. Basic operations. So in this scenario, everything went well, but since we already got a winner, so we won't be able to get another winner in this scenario. But as you can see that we got out of the gumballs, the machine said we are sold out, so we can't give you the gumball. So this is the working and scenario of our entire code. Thank you so much.